minus, and the square root of 60 is 4 and 15, 4 times 15. So that's going to be 2 times the square root of 15 all over 2, which I'm going to have to bring this all the way back over here. And my answer, actually I want to come more that way. My answer is going to be y is equal to 2, not 2. 4 plus or minus square root of 15, and then that's it. Okay. So 4 plus or minus square root of 15 is y, but you know y was equal to e to the x. So now I have to say e to the x is equal to 4 plus or minus square root of 15. Okay. And then to go further, I have to say, and I'll move it up here. Erase all that up there. I know y'all like this is a crazy problem. It is. So we'll start with e to the x equals 4 plus square root of 15. Okay, take the natural log of both sides. I got natural log e to the x equals natural log of 4 plus square root of 15. Okay, and then move that x out front. X ln e equals ln 4 plus square root of 15. And then this cancels out because ln of e is 1. So x is equal to ln 4 plus square root of 15. Okay. I know, it is crazy. And then we have to do the same thing for minus. But we know when we get down to it, our answer is going to be the same. So it's going to be or x equals ln 4 minus square root of 15. Okay. Now the problem here, well, it's not really a problem. It is almost a problem. But if this had been more than 15, or let's say more than 16, I'd have had ln of a negative number, which means this wouldn't have worked. But right now, it's okay. It's still going to be positive because 4 is greater than the square root of 15. So my answers are x equals ln 4 plus 15, square root of 15, or x equals ln 4 minus square root of 15. And I know it's a long problem, but we had to do it that way. And if I messed up, email me. Because I could have messed up somewhere, but I don't think I did. But check me as always. Alright, so that's it for that one. That was the longest one. That's why you got that one problem on that big sheet of paper. Alright, the next one. We're talking about exponential growth, 5.6. And we're given P of t equals P naught e to the kt. Okay? Where k is your growth factor, P of t is your growth rate form, P naught is your initial population. That's at time 0 when nothing has happened. E is that natural number, 2.718. But using E from your calculator as it says on paper. In case your exponential growth rate is positive, you're going to use it in decimal form, and then T is the time in various units. So it says question 1, the population of Bayab in 2012 was 5.48 million with an exponential growth rate of 1.87%. A, find the exponential growth function. So we're just going to plug in what we know, right? So this is A. P of T equals 5.48, because that's my initial population, e to the 0.0187 times c. Don't know what the years is, so that's my exponential growth function. Okay, only thing I don't know is t, which will help me get any type of answer. Okay, so then it wants to estimate the population in 2018. Okay, my initial population was 2012. So how many years are gone by? 6. So B is P of 6. So the only thing I'm going to do is multiply that 0.0187 times 6. And I can put that in the calculator just like that. 5.48 e to the 0.0187 times 6. So I'm going to do that. And I get P of 6 equals 6.1307. Okay? And remember, this is million. So that is million people in 2018. 6.1307 million people in 2018. And then it says, in how many years will the population be 7 million? So we know it's going to be more than 6, because in 6 is 6.1307. So now we're going to put in 7 million for P of t and then solve this equation. But we're going to erase it and do it right there. What did I do with that eraser? Oh, it's right here. Okay. So now we can put in 7 equals 5.48 e to the 0.0187 times c, and we're trying to find t. Okay, so we're going to need to use some natural logs. First thing I'm going to do is divide by 5.48. So 7 divided by 5.48 equals e to the 0.0187 times t. Okay. Then I'm going to take natural log of both sides. So I got natural log 7 divided by 5.48 equals natural log e 0.0187t. And remember, this just comes to the front. And then I got 0.0187t equals natural log of 7 divided by 5.48. And I'll just put that in parentheses like that so you know. Okay. Last step, I want to get t by itself. I want to know how long it takes. So I'm going to divide by 0.0187. So t is equal to natural log of 7 divided by 5.48 divided by 0.0187. Put that in the calculator like that. I know it looks crazy, but we're going to do that and get an answer. First thing is put that, and I would put this, if I were you, in parentheses on your calculator. So put parentheses around it like that to help you not mess up. And then when you get done, you should get time. T is equal to 13.09. And this is going to be years. Okay? So 13 years is approximately what it's going to take for it to reach 7 million. And we knew it had to be more than 6 years, so that makes more sense. So that means if we start in 2012 and 2025, or during 2025, we'll reach 7 million people if it continues on course like it is. Okay? So that was C. Okay? This is letter C. Now, in D, it says, in how many years will the population be double what it was in 2012? Okay? So let's work that out. And then on the next problem, you'll see it's an easier way to do this. Okay, so if I double my population, it's going to be 10.96. So we're going to say, for D, 10.96 equals 5.48 e to the 0.0187t. Okay, because that's double. That times 2 is 10, that times 2 is 0.96. Okay, so I'm going to divide by 5.48. And if I divide by 5.48, I better get 2. That cancels. And I got e to the 0.0187t. Now I want to take natural log just like I did last time. So natural log of 2 equals natural log e of 0.0187t. And those go away. We got natural log of 2 equals 0.0187t. Y'all know this goes down to the front, so that's why I could do that. Okay, finally, I want to divide by my growth factor. And then I get T equals ln2 divided by 0.0187. Okay. Now, I told you on the next problem it's going to be easier to figure this out. Anytime you want to talk about double the rate, or half-life, is ln2 divided by your growth rate. That's the easy way to figure it out. So how long is it going to take to double? Let's say ln2 divided by 0.0187. And we got 37.0666 and some more years. Well, 0667 if we round years. Okay, because it was 0.06669415. So that's just over 37 years for it to double, which is a good long time. But we're talking about exponential growth. Okay, so that's good. And that's just for it to get to 10.96 million. Okay. So growth rate and doubling time is at the top of this next slide. It tells you K times T equals ln2, or K equals ln2 over T, or T equals ln2 over K. And then we're talking about money on this next one. $11,628 is invested at 6.7%, compounded continuously. That's where the E comes from. And we talked about that a little bit last week, but we're going to talk about it more this week. We want to find the balance after 10 years. So after 10 years, you put 10 in for T, and you get, $22,723.87. That's already on your paper. Now the question is this double? Well, if we started with 11,628, we should be above 23,000 when we double. So no, it's not double. It's not quite there. So we're going to use our shortcut to find out how long it doubles. Okay, so I'm going to put that up there. So we have time it takes equals natural log of 2 over the growth rate, which is 6.7%, 0.067, which is approximately 10.3 years, not 7. And this is actually on your slide, so you see that, but that's how it does it. So it's just over 10 years to double. Because we were almost there at 10 years, but it's more than that to actually double. Alright, so we got a desk for the next one. It was bought for $261 in 1977 and sold for $493 in 1990. Did it double? No. Okay, and we want to find K. So you got K equals ln2 over T. That's only if it doubles. And it did not double, so that formula cannot be used. We must use the original formula. Which was A of T equals A naught e to the KT, right? And we know how much it was bought for, that's A naught, and then how much it sold for, that's $493. And we know the time passed is 13 years. So we can say $493 equals 261 e to the k, which is, we don't know, so that's what we're trying to find, but my time is 13 years. Okay? So to solve this, first thing we're going to do is divide by 261. You get 493 over 261 equals e to the k 13, again, natural log. Okay, and we're going to take this k times 13, we're going to move it in front. And that's going to go away, so we got k times 13 equals ln 493 over 261. And then we divide by 13. Okay, it's going to go away. Then we got k equals ln 493 over 261 divided by 13. So again, going to put that in our calculator. And again, make sure you put this in parentheses. 'Cause if you don't, your answer might be messed up. Might be, I'm not for sure. And then I got my K equal to 0.0489, which is approximately 4.89%. Okay. That is my growth rate. Okay. If I change it to a decimal. Alright. And we got exponential decay. Okay, exponential decay is like growth rate, but it's going down instead of up. So everything you're talking about is going to get less. It's going to become less. The difference in the function is we got P of t equals P naught e to the negative kt instead of positive kt. Okay, and that's your decay rate form. K is positive, that's why that negative is in front of it. Okay. So if we look at decay rate and half-life on the next slide, we got the decay rate, K, and half-life T are related by K of t equals ln2 or K equals ln2 over T or T equals ln2 over K. That's when we're talking about half-life. It's like double time, but it's half-life this time instead of double. So number one says a substance has a half-life of 106.3 minutes. We want to find its decay rate. So we want to find K. And they show you on your slide that K equals ln2 over T. So we're going to put ln2 over the time, 106.3, in the calculator.
That's all blurry.
So we got ln2 divided by 106.3. And I got K is approximately 0.0065. Okay. Or 0.65%. Okay. It's still less than 1%. So my decay rate is still less than 1%. Alright, so the next one says a substance decays at a rate of 1.15% per day. Find its half-life T. So we want to find the half-life, we want to find T, so we can use T is equal to ln 2 over K. It's up there. So we're going to say T was ln 2 over K as a decimal, 0.0115, this is 1.15%. So T is approximately 60.3. We'll round it to the nearest 10. So it's going to be T is approximately 60.3, and our time is in days, so days. Okay? So that's how you do that one. It's pretty simple. Just use those formulas that's right on the top of your paper. Okay. Last one. It says carbon-14 has a half-life of 5,750 years. So we know, and if you look at the arrow on your paper, K is equal to ln2, which equals ln2 divided by how long it takes. And we're talking years here. That's 5,750 years. That's half-life. Okay? So my K is approximately very small. 0.0001 0.1205. Okay, and that is decimal, right? So that's not even percentage. As a percentage, it's approximately 0.01205. Move that over 2 places. Okay, so it says Macedon was found that had lost 83.8% of its carbon-14, so it has 16.2%, or blank of its original carbon-14. So we're going to say 16.2% of its original carbon-14. Okay, that blank I should take off your slides, but if I don't, just ignore that. It's 16.2%. And then the next thing says, how old were the bones at the discovery? And we run around to the nearest integer. So we will solve for t using P of t equals P naught e to the kt. Okay? So if it had 16.2%, we're going to put that in there. And I'll write it on the board. So, that's negative because we're doing exponential decay. Alright, so we know we got 0.162 P naught equal to P naught e to the negative, what was that, K? 0.001205 times T. Whew. Alright? So we can find out how old these bones were. Okay? So my P naughts cancel because this is 16.2%, but they're going to go away. Okay? If that was 100%, it would be 1. So 1 and 0.16 is going to be what's remaining. So now I got 0.162 equals e to the negative 0.001205 t. And then my calculator, I still have the whole number. So when I get an answer, it's not going to be using this rounded number. It's going to be using the original number. So you might want to keep the original number in here if you can. Alright, so then I'm going to take natural log. So natural log 0.162, natural log e, negative 0.0001205 t. And again, this goes to the front, that cancels. So now we got natural log 0.162, it was negative 0.01205 t. Okay, and then we're going to divide by negative 0.000205. On this side, the same thing. 1205. And we get t equals natural log of 0.162 divided by negative 0.001205. And then I'm going to put this in my calculator. Okay? And to use the original number, I'm just going to put natural log of 0.162 divided by, and then I'm going to hit second answer. And that'll put that whole number in there. Okay? Now, for some reason, I'm getting a negative. Did I mess up somewhere? I think I didn't divide by negative. I'll try this again. I'm just going to put those in there because I messed up somewhere. I forgot to do negative answer. So I just put a positive in there, and that's why I got a negative answer. Let me try this again. So natural log of 0.162 divided by negative second answer. There we go. And I had the same number, it's just negative instead of positive. So my time is approximately 15,099 years. So approximately 15,000 years old are these bones. Or 15,099, because it said round to the nearest integer. Okay? So we know our decline and decay function as PT, because P naught e to the negative KT. We know what K is, negative 0.001205. And then T is going to be the same. And my decay rate is going to be K, which is 0.001205 approximately. And those are the bottom things on your paper. So do we know P of T? Only if we're given how long it's been or how much it has left. So we did that to find P of T. Do we know P naught? No, we don't know what P naught is, but it doesn't really matter. But we can find K, and we did. Alright? And that is it for today. Like I said, if you have any questions, make sure you email me. That's the end. You gonna watch that over?